All right, how's everybody doing today? Can you hear us okay, or should I be louder, quieter? Louder? All right. Pettee, why don't you say something? Let's see if they can hear you.
You guys hear me? Yeah.
All right, Pettee's loud anyway, so. So we're going to show you guys today some fun with liquid nitrogen. Liquid nitrogen is one of my very favorite things that I get to play with in my job. It is one of the very coolest things that I get to use. Pettee, do you remember just how cool liquid nitrogen is?
200, negative 200 Celsius?
Yeah, so that's pretty cold. For those of you that don't think in Celsius like we do, because we're scientists, that's about 350 degrees below 0 Fahrenheit. So nitrogen normally is in the air that we breathe. So if everybody takes a deep breath, we can taste that nitrogen, right? Not so much, really, because it's colorless. We can't see it. We can't really taste it. It doesn't have a smell. But if we get it that cold, if we get it down to about 350 degrees below 0, like I said, but that was Fahrenheit. What was it in Celsius, Pettee?
200.
200
Negative
degrees
200.
below 0. So 200 degrees colder than where ice freezes. If we get the air that cold, then that invisible gas turns into a clear liquid. And I can pour a little bit out, and it looks just like water. But if I poured water onto the stage, I'd get a puddle, right? Do you guys up front see any puddles up here? So where do you guys think it went? It turned back into air. It evaporated because it's pretty warm in here. And that nitrogen doesn't want to be a liquid. We have to get it really cold to get it to turn into a liquid. So as soon as it comes in contact with the air, or as soon as it comes in contact with the floor, it's going to evaporate and it's going to turn back into a gas. Now, I'm going to let Pettee hang on to this because Pettee is going to be doing the afternoon show by herself. So I'm training Pettee here how to do this. So Pettee, if it's that cold, do you think it would be a good idea for us to get it on our skin?
I don't know. Let's ask
What do
everybody.
you guys
What do you guys think?
No, probably not. All right.
You want to see me do it?
But how many of you guys would want to see Pettee try it anyways? I see a few hands out there. Pettee, can she actually safely pour just a little bit on her hand, do you think? Let's try it. As long as she pours nice and slow, she can actually pour it on her hand. Because did you guys see how fast it evaporated when I poured it onto the ground? Real fast, right? It just disappeared right away. Do you think Pettee's hand is warmer or colder than the floor? Warmer. So do you think that's going to make it evaporate faster or slower? Faster. In fact, the air around Pettee's hand is so warm that most of the nitrogen evaporates before it even touches her skin. So as long as she pours it nice and slow, she doesn't have to worry about freezing off her hand. Now, what if she poured it really fast? Faster than it could evaporate. Would that be good? No, because then it would be touching her hand, and that would be bad. Did you guys notice that she was holding her hand pointing down so that if she poured too much, what would happen to it? It would just roll right off, right? What if she did her hand like this? Would that be a good idea? No, because then she'd be holding that liquid in her hand, and that would be very bad. We'd get frostbite, and then Pettee would have to go home, and I'd have to run this whole thing by myself, and so let's not do that. So if we can pour it on our hands and that's safe, what about these balloons? How many of you guys think that if we pour nitrogen onto these balloons that they'll pop? A lot of people think that. How many people think that maybe something else will happen, but maybe we're not sure what? So we've got some people that think they'll pop, and we've got some people that think that something else will happen, but they don't think they'll pop. You guys look like scientists up here. How would a scientist figure it out? Should Pettee and I arm wrestle and whoever wins gets to be right? Is that scientific? No, what should we do? How could we figure out what's going to happen? We can do a test. We've got some smart kids up here. We can do an experiment. So Pettee, why don't you take our nitrogen and let's actually try this out. Let's pour some nitrogen onto our balloons and let's see what's actually going to happen. Well, it looks to me like we took the air out. I didn't hear any explosions, though. Did you guys? I didn't hear them pop, but they sure looked flat.
want one.
Let's take one out and look at it here.
I want the pink one.
You want the pink one? I'm going to take this blue one out here. So it doesn't look like there's any air. Oh, wait a minute.
Something's happening.
Something's happening here. Why don't you try turning it upside down and see if that goes any faster?
Yeah.
Shake it up a little bit. So the air didn't disappear, did it? It was in there. It was just hiding. Let's look at a couple more.
I'll take the yellow.
So what's happening is when we talk about temperature, when we talk about whether something is hot or cold, in science what we're really talking about is how fast all the little pieces are moving. So inside this balloon, there's lots and lots of tiny little pieces of air. We call those pieces molecules. So there's thousands and thousands of air molecules inside the balloon. And right now, this one's warming up, so this one's about the same temperature as the room again. So those molecules are all moving pretty fast. And when they move around fast like that, they push on the sides of the balloon. Just like if you guys were all in a room, you'd bounce off of the walls, right? If we got you guys all hyper and pumped full of sugar and then put you in a small room, you guys would all be bouncing off of the walls, right? Well, that's what's happening inside this balloon right now. All of those little air molecules have a lot of energy. They're all moving around a whole lot, and they're bouncing off the walls of the balloon. But these guys in here, they're nice and cold. So those molecules have gotten lazy. Those molecules have slowed down, so they're not bouncing around. They're not pushing as much on the walls of the balloon. But when we take it out and we let that air warm back up, then it blows the balloon back up. Pettee, you want to get the red one there?
I'll do the husky red.
So there's actually something neat going on inside the balloons beyond just the air temperature, but we can't see it because these balloons are colored, right? So we can't see the air. Let's look at a different balloon. We've got this colored balloon, this clear balloon. So now we can see the air in this one, right? Can we see the air? No, I tried to trick you, but you guys were too smart. We can't see the air, but we know it's in there because the balloon is inflated, right? It's blown up. So Pettee, why don't you go ahead and take this nitrogen and pour it into our bowl here. Nope, use this one. We want to save what's in there for the next show.
Aha.
So Pettee's going to pour our nitrogen into a bigger bowl here. We can see it's making lots of cool, creepy fog. I'll talk a little bit more about why that is in a second. So now let's take this clear balloon so that we can see what's happening, and we're going to stick it down into the nitrogen. Now, we could pour the nitrogen on our hand a little bit. Do you think we want to actually put our hand down into the nitrogen? No. So I'm going to give Pettee a spoon here, and once it gets close enough that her hand starts getting cold, she's going to use that spoon to put more nitrogen on top of the balloon, because we want to get him good and cold so that all of that air is taking up as little space as possible. And something really neat's going to happen. Do you remember where I said the nitrogen came from in the first place? Where do we get nitrogen from? Remember I had you take a deep breath? So nitrogen comes from the air, and if we get air cold enough, then that nitrogen turns into a liquid. So what do you think's going to happen to the air inside of this balloon if we get it that cold? It's going to shrink, we already saw. I think we're good there, Pettee. Why don't we take him out?
Okay, go.
So now you guys in front are going to have to be the eyes for everybody. Can you guys see some liquid in there? You guys are looking at the air. Now you can see it because we got it so cold that it turned into a liquid. So now we have some liquefied air inside of this balloon. And just like before, if we kind of shake it up and spread that liquid out, then it'll evaporate faster. And now our balloon turned white. But it didn't actually change color. It's just foggy is all, or frosty even. Because inside of this balloon, besides just having air, there's some moisture, right? Have you guys all heard the word humidity? That's the moisture that's in the air. Well, air is kind of like water. Have you guys ever made rock candy before? Where you mix sugar into hot water, and then as the water cools down, it won't hold as much sugar, right? So the sugar condenses out. Well, that's the same thing that happens with fog. The air can hold moisture in it, just like the water holds sugar, but cold air doesn't hold as much. So when we made that air really cold, that moisture condensed, and we could see it as fog. But now that it's warmed up again, do you guys see any more fog? Nope, because now that the air is warmer, it can hold that moisture again. So now all of the fog disappeared. It just went back into the air. So let's set him aside over here.
Here, I'll take him.
We're going to take this and pour it back into here. Oh, actually, not all of it. So if we can shrink balloons with liquid nitrogen, do you guys want to see us blow up a balloon? I think that sounds like a fantastic idea. So we've got a great big balloon here, but now Pettee's going to put her gloves on. Because before, when we poured it on our hand and we did it on purpose, remember we had to be very careful, right? We had to make sure that we only poured a little bit and we had to hold our hand a certain way. Well, now Pettee's going to fill up this bottle, and she's going to fill it almost all the way up with liquid nitrogen. And we don't want her to spill it on her hands accidentally when she's not trying to. So she's going to wear her special gloves. It's always very important to wear the right safety equipment when you're doing science, because science can be a lot of fun, but if you're not careful, there are things that can be dangerous too. So Pettee's being very careful. She's pouring nice and slowly. She's got her gloves on. And when she's got it filled, we're going to take this big balloon here and we're going to put it on the top. And what's going to happen is the nitrogen is going to boil. Because remember, it doesn't want to be a liquid. It wants to be a gas. It's too warm in here for it to be a liquid or for it to stay a liquid.
Okay, ready?
So we're going to take this balloon, and Pettee's going to stretch it. Oh, let's get a little bit out of there. Fill it up to about the neck. I want to make sure it's not going to pop. There we go. All right, so now Pettee's going to take and put that balloon on there. Oh, I need a bottle of water. I forgot about that.
Does anybody have a bottle of water?
So we can already see the
This
balloon
one's
is starting to fill up a little bit. Yeah, we're all out of clown balloons. Our clown balloons for the year haven't come in yet. So we're using the big orange balloon. And, yep, we do want to pour the rest of this in there now.
Oh, look at
Oh,
that.
all right. So our balloon is filling up because our nitrogen is evaporating, but it's not filling up very fast, right? We've only got a half hour, and I'm sure you guys have got lots of other things you want to see. And this balloon is going to get just gigantic. So I think we need to find a way to speed this up. Let's add some more energy.
Thank you.
So right now it's taking energy out of the air. But air likes to hang on to its energy. Air is what we call an insulator. So let's add some water to the mix. Oh, you got one too?
Yeah.
We're going to add some water into the bowl, and that's going to make it easier for that nitrogen to evaporate, because now it's going to be able to take energy from the water instead of taking it from the air. In order for things to get warm or cold, we can't just invent energy. We can't just create it. All we can do is move it from one place to another. So right now, we're moving the energy from the water into the nitrogen. The nitrogen is taking that energy, and it's using it to make its molecules move faster, and so it evaporates. And in the process, the water is getting colder. So it shouldn't pop. Well, I actually have the bottle specially measured so that this one won't pop, because it would take a really long time to pop. But we're going to come back to it in just a minute. In the meantime, Pettee, since you've got the gloves, can you pick up our bowl and move it over to the side, because I want to get back into the doer here. So you guys might have noticed that our nitrogen container here has a special top on it. It doesn't screw on, right? Because if that's what's happening to the balloon, what do you guys think would happen to this container if we screwed the cap on tight? It's going to evaporate and it's going to build up pressure, right? Until finally this thing would explode, and that would be bad. So any kind of nitrogen container like this has a cap that'll float. So if it needs to release pressure, the cap will just pop up a little bit and let some air out. But let's look at what would happen if we didn't have that cap. So we've got here, some of you guys maybe have never seen one of these before. This is an antique. This is something called a film canister. Years and years ago, cameras used to use something called film, and this is what they came in. So we're going to take a couple of those, and, oh, actually, we need to get back in there. Pettee's going to take just a tiny little scoop. Just put a couple drops in each one. Oh, that one went too fast. Oh, I think we used that one up. So Pettee just put a tiny little drop in there. And I can't even put the lid on. Oh, it's gonna there we go. Sorry about that. That's why I use tiny little things to do that one. So if that thing shot off of there like that with just a tiny little drop of nitrogen, what do you guys think would happen to this big can here, or this big container? It would take out a whole room, right? What's going on with our balloon here, Pettee? It doesn't look like it's gotten any bigger. I think it's getting smaller.
There's a hole.
Oh, no. Our balloon has a hole.
Yes.
Okay.
Unfortunately.
Well, that's a problem.
Big problem.
That is a problem. Yep, so we'll... That one takes a while, so maybe let's just move on to the racquetball. So now, some of you guys might have noticed that I dropped a ball in here a little bit ago. And actually, here, you can use the other glove. I'll take a second here. So do we have another balloon, or are you just going to... Okay. So one of the things that we do with liquid nitrogen at the university, besides just have fun with it, which we do have a lot of fun, we like to blow up balloons, and we make ice cream. If you guys have ever, I know there's some people I've seen today that have been to our camps. Every year at camp, we always make ice cream with liquid nitrogen. So that's a lot of fun. But some of the other departments, they actually use it for research. And they study something called cryogenics, which is what happens to things when we get them really, really cold. So I've got a racquetball here, which is pretty bouncy. So we're going to look at what properties change if we freeze this racquetball with liquid nitrogen. So when we use the word properties in science like that, we basically just mean how can we describe it. So you guys up front here, what are some good scientific ways that we could describe this ball? It's elastic. It's definitely bouncy. What else do we notice about it? What shape is it? It's round. It's a sphere. What about the color? It's blue. So those are pretty much, I think, the biggest characteristics here. We've got a bouncy blue ball. Well, now we've got one in here that I put in the liquid nitrogen a little bit ago, and so it's probably nice and cold by now. So let's take it out and let's see if any of the properties have changed. Do you guys think it's still round? Do you think it's still blue? Let's take a look. Yep, it is still round, and it is still blue. Do you think it's still elastic? Whoa! Watch out. There we go. All right, the stage is not hard enough to break it. But as soon as it hit the concrete, it shattered into little pieces. And they're probably already cool enough to, or warm enough to touch. Yep. Because the rubber's not very thick, so it doesn't stay cold long. So if you guys want to come up when we're done and check out, we've got little pieces of broken racquetball now. How many of you guys know what the word density means? So density has to do with how much stuff you have packed into a certain amount of space. So if you've got a pound of feathers and a pound of bricks, which one's going to weigh more? A pound of feathers and a pound of bricks. How many people think the feathers? How many people think the bricks? How many people were smart enough to catch that they both weigh exactly 1 pound? But the bricks are more dense. It doesn't take as many bricks to make 1 pound. So right now, we're taking this bottle and we're filling it with a certain amount of liquid nitrogen, and then we're going to add the balloon. So it has a certain amount of weight. It has a certain mass. Is that going to change? No, because we're not losing anything. It's turning into a gas, but we're not going to lose it. We're still catching it. Yep, you got to make sure that it doesn't freeze right around the neck, so I usually kind of just keep touching it. So right now, this bottle and the balloon all together has a certain mass. And that's not going to change because we're not adding or taking anything away. But is the size going to change? Yes, it's going to spread out. So something neat is going to happen once it gets there.